I'm Ms. Ulrich, and in this video I'm going to teach you how to use function notation to solve for variables. So we've talked about function notation a little bit already this year. Function notation is when we write f of x, it means the function of x. So basically what we're going to do is use this notation to understand what letters we're substituting or what numbers we're substituting in for the x value. Now understand f of x could also be written as g of x or as h of x. And again, we've talked about all of those three as well. It could be any variable really, and it all means the same thing. All of these three things are the same thing as the y value. So keep in mind, anytime you see any of these, I'm really just asking you for the y value. So let's say that I give you the function f of x equals 2x plus 3. Okay, first of all, understand again that f of x, this just means y. So we could rewrite this as y equals 2x plus 3. Again, it's the same thing. Now, the reason we use f of x instead of just writing y, though, is to find problems that are written like this. So if it asks us to find f of negative 1, basically what that means is it wants us to find the value of y when x is equal to negative 1. So we're going to change the x in this problem to a negative 1. So I'm going to rewrite this as f of negative 1, because that's what I'm solving for, is equal to 2, and instead of the x again, I'm going to replace it with a negative 1 and then plus 3. So again, f of negative 1 is equal to 2 times a negative 1 is negative 2, and then we have negative 2 plus 3. So f of negative 1 is equal to negative 2 plus 3, which is a positive 1. So really, ultimately, we're saying that the y value here is equal to 1, and this is our solution for this type of equation. So this is a similar problem. Here it's asking us to find f of 5. So again, this is usually written f of x, and that means that I want to change the x to a 5 in this equation. So I'm going to take x equals 5 and plug it in where I see that x value there. So I'm going to find f of 5 is equal to negative 2 times 5 minus 4. So then we have again f of 5 is equal to negative 2 times 5, which is a negative 10. And then we bring down that negative 4. So f of 5 is equal to negative 10 minus 4, which is negative 14. And again, that f of 5, that's just the y value. So when the x value is 5, the y value is negative 14. I could write this as a solution. And the solution, when I say that, what I mean is the coordinate. So the solution here, when x was 5, the y value was negative 14. So for this one now, we're asked to find g of negative 2. So remember again, this is generally g of x, and what I've done is they've changed the x to a negative 2. So that means I'm taking this negative 2 and replacing it where I see that x in that problem there. So I'm going to rewrite this as g of negative 2 is equal to negative 2 squared minus 3. So again, I'm solving for g of negative 2, and that equals negative 2 squared. That's a positive 4, because negative 2 times negative 2, which is what negative 2 squared means, gives me a positive. And then we're going to bring down that minus 3 there. So now we have g of negative 2 equals 4 minus 3, which is 1. So ultimately, the solution here, we're going to have y equals 1. And for my coordinate, my actual solution, I could rewrite this when the x was negative 2, the y value was 1. Okay, so that would be the final answer there. Okay, let's try this one. This one's h of negative 4 equals 3x minus 7. So again, usually this is written h of x, and here they've changed the x to equal a negative 4. So I'm going to take that negative 4 and plug it in where I have that x value. So I'm going to rewrite this as h of negative 4 is equal to 3 times negative 4 minus 7. So here again, h of negative 4 is equal to 3 times negative 4, which is a negative 12, and bring down that minus 7. So we have h of negative 4 is equal to negative 12 minus 7, which is negative 19. So ultimately, this is the y value. So the y value is negative 19. For the final solution then, for the point that it would be at when x is -4, the y value was -19. So that would be the coordinate there. All right, let's try one more like this. So this one we're going to find f of 9 equals -x plus 6. So remember, this is usually written f of x, and in this case they've changed the x to equal 9. So I'm going to take that 9 and plug it in where I have that x there. So this is going to become f of 9 is equal to -9 plus 6. And understand that this is actually a -1 in front of that x there. So this is f of 9 equals -1 times 9, which is a -9, and then plus 6. So here we have f of 9 equals -9 plus 6, which is a -3. So ultimately the y value then is -3. And if I were to write my final solution, then the coordinate with which it is at, when x was 9, the y was -3. So that would be the coordinate there. Okay, this type of problem looks a little bit different. It's really not too far off from the same. So here it's asking us to find the values indicated, and for h it gives us all of these coordinates. Now keep in mind, for each of these, the x values come first, followed by the y values. So each of these are our x values, and each of these are our y values. So when I'm asked to find h of 6, remember that's really like saying h of x. So for h of 6, I'm saying that the x is equal to 6. So I'm looking across this graph here, across these list of points to see where my x is equal to 6. And if you notice, we have it right here. So therefore, when x is equal to 6, I want to know what the y value is. And the y value there is 12. So the answer to h is h of 6. I want to look for the output, and the output there was 12. Okay, I want to do the same thing for each of these. So the second one is h of -2. That again means that the x value is -2. So I'm going to scan across my list of points here, and I'm looking for where the x is -2, and I notice it right here in this first coordinate. Now I want to know what the y value is, the output of it, because h of the function is equal to y. So the y value when x is -2, the y value is 6. So that's my solution here. Same thing with the last one. We have h of 8. So h of 8 means that I'm looking for where x is equal to 8. And again, scanning across my graph, I'm going to look to see where I have x is 8, and it's this last one here. And I'm looking again for the y value there. So the y value, the output from that, when x is equal to 8, the y value is 14. So that is my solution for each of these. Okay, so here we have a problem where it's going to be multi-steps. It says if f of x is 2 minus 3x, and g of x is 2x squared minus 1, find the following. This is really why we use different variables in front of the x, the f of x or the g of x, to differentiate between two expressions. So f of x equals 2 minus 3x, and g of x equals 2x squared minus 1. Now, the first thing I'm going to find is f of -2. So I'm looking for f of -2. Because I'm using the f, I'm going to use this function here. So I'm going to say f of -2 equals 2 minus 3x. And again, because I'm changing this x here to a -2, I'm also going to change the x in the problem to a -2. So I'm going to rewrite this then as f of -2 equals 2 minus 3 times -2. And to solve for that, we have f of -2 equals 2, and then -3 times a -2 is a positive 6. So we have f of -2 equals 2 plus 6, which is 8. And remember, this is really the y value. So the y value here is 8. So the first one, f of -2, the answer would be 8. Okay, for the second one, I'm asked to find g of 5. So here I have g of 5. And in that case, I'm going to use this expression because I'm using the g one. So I'm going to set it equal to that equation, which was 2x squared minus 1. And remember again, because this is the x value, I'm changing the x in my equation to 5. So I'm going to take that x and plug it in here where I have that x value. So we're going to rewrite this as g of 5 is equal to 2 times 5 squared minus 1. Okay, so now this one is going to require some multi-steps. I have to always start with exponents. So we have 2 times 5 squared, which would give us 25. And then bring down that minus 1. So then I have g of 5 is equal to 2 times 25, which is 50, and then minus 1. And then finally, g of 5 is equal to 50 minus 1, which is 49. So again, this is your y value. Your y value will be 49. So the answer to the second one would be 49. Okay, and the last one now, I'm going to have to do some multi-steps. So the first thing it asks me to find is f of 4. So I have f of 4. And then plus g of negative 1. Let me just start with this to start off with. Because I'm using the f of 4, I have to use this expression because that's the f values. So f of 4 is equal to 2 minus 3x. And again, because this is the x value, I'm going to change the x in this equation to be a 4. So I'm going to rewrite this as f of 4 equals 2 minus 3 times 4. So we have f of 4 equals 2 minus 12. 3 times 4 is 12. And then f of 4 is equal to 2 minus 12, which is a negative 10. So ultimately, this gives me a y value of negative 10. Keep in mind, that's the first answer to this. Now I have to come up with the second one as well. So for this one, I'm going to start with my g of negative 1. So we have g of negative 1. And because I'm talking about the g this time, I have to use this expression. So g of negative 1 equals 2x squared minus 1. And again, keep in mind that because this is the x value, I'm going to change the x to a negative 1. So this x right there is going to become a negative 1. So I'm going to write this as g of negative 1 equals 2 times negative 1 squared minus 1. So we have g of negative 1 equals 2, and then negative 1 squared gives me a positive 1, and then bring down that minus 1, and then g of negative 1 equals 2 times 1, which is 2, and 2 minus 1 finally. So we have g of negative 1 equals 2 minus 1, which is 1. So finally the y value here is a 1. Now, go back and look. What it wanted us to do was add the two answers. So my answer to the first one was a negative 10. My answer to the second one was a 1. So we have negative 10 plus 1 is equal to a negative 9. Ultimately, this is what we want to do. And again, I got that by saying negative 10, my first answer, plus 1, my second answer, equals a negative 9. So this is the answer finally. That help you to understand how to use function notation to solve for given variables. Please be sure to ask questions in class and make sure you go back and rewatch any parts that you don't understand. I'll see you next time.